Okay, on to this next question, which is a coordinate geometry question. It is worth 6 marks, so there's quite a few marks in there. And I guess it looks a bit scary because there's not much to it. It's quite unstructured. Hey, but we can do it. It's only going to involve our coordinate geometry skills, so it's all going to be fine. What I like to do with coordinate geometry questions is actually kind of sketch out a little bit what I think it might look like. So I might say, for example, I'm going to put this point here as being the point A2, and maybe another point over here as being the point 3B. I have no idea where these points are, but it just kind of helps to see it visually. And we're going to find out what these values A and B could be. We know that the distance between the 2 points, between there and there, is the root of 125. And we know normally how to work out our points, which is to use Pythagoras. So all I'm going to do is just draw for myself on the right angle so I can see where that sits. And what I know is that this point here is going to be the point 3, 2. And I know that the length of this is the root of 125. So I'm going to start my first equation. So if I look first of all at this length of the triangle, I need to work out what the width of the triangle is. So it's going to be 3 minus a. Whatever a is, 3 minus it will be what the width of that one is. So it's going to be 3 minus a all squared. I'll do the same thing for the height. So whatever b is, I'm going to take 2 off it to get the height of it. So b minus 2. B minus 2 all squared. Those things added together is going to give me 125. And in case you're wondering about which way I subtracted it, it doesn't actually matter if you had put a minus 3 or 2 minus b here, because all you're doing is trying to work out is how far apart they are, and you end up squaring it anyway, which will make it a positive number. So don't worry too much about whether you wrote it the other way around. It'll all work out fine in the end. Okay, the other thing that I know is that the gradient of this line is 2. So the gradient of this line is 2. And how you get gradients is you get the change in y over the change in x. Right? So normally for our gradient, we take our 2 y values and our 2 x values, and we subtract them to get the change. So I can do the same thing here. So my 2 y values is going to be b minus 2. Okay, so that's my b minus 2 there. And then my x values is going to be 3 minus a. And what's really important in this case is it does matter which way around I put these ones. So I've used this coordinate as the first coordinate, so the y2 and the x2. And I've used this coordinate as the second coordinate, so the y1 and x1. And so I do have to make sure those things are the same. So b minus 2 and 3 minus a. So what we know is that the gradient comes out to equal 2. And now we have two equations. We've got an equation here and an equation here. Both are in terms of a and b. We want an equation that's just in one variable so that we can solve it. What you can hopefully see is that this b minus 2 is part of this equation here. So what we could quickly do is rewrite this as 6 minus 2a equals b minus 2. So all I've done is multiplied out by the 3 minus a, so 2 times 3 is 6, and 2 times minus a is minus 2a. And now I've got b minus 2, and what I can do is actually replace this b minus 2 with 6 minus 2a, and that'll give me this whole equation here to solve. So if I go ahead and do that, I'm going to get 3 minus a all squared plus, and rather than the b minus 2, I'm going to replace that with 6 minus 2a all squared equals 125, which is pretty cool. I'm just going to give me a clear space there. Right. Next thing really is hopefully you should be able to see at this stage that we have a quadratic. We've got our squares and we've got numbers and stuff. What we're going to do is tidy this all up so it looks like ax squared plus bx plus c equals 0, and then it's just a quadratic that we know and love and can solve. So we need to expand out these and then group everything up. So remember that when we're expanding this out, that this is 3 minus a times 3 minus a. So you're actually going to get 9 minus 6a plus a squared for that one. And for this one, okay, and here we're going to get 36, which is easy, 36 minus 24a plus 4a squared, and that all equals 125. Let's group that all up. So we're going to end up with 5a squared minus 30a minus 80 equals 0, and that's just by grouping the 9 with 36 together, which makes 45, but then taking off the 125, so we get 80. And just to make life even easier for myself, I'm going to divide through by 5. So I'm going to get a squared minus 6a minus, what is that, 5, 30, 16. 16 equals 0. I'm just going to make a bit of space for myself. Here we go. Yeah. Cool. So I should better factorise this if all's gone well. So two things that multiply to 16, that's negative 6. So that's going to be negative 8 and a plus 2 equals 0. So that's going to mean that a equals 8 or a equals negative 2. They're asking for the possible values of a and b, so I need to find the pairs of those values that go together. So that's cool. So, and if I use this equation here, I should be able to do that. So when a is 8, I could put a equals 8 into here. Okay, and if I solve that, I'm going to find out that b equals minus 8. So that goes together with that one. If I do the same thing for the negative 2, I'm going to find out that b equals 12. And then I'm done.